Calculate the electric field at one corner of a square 1.22 meters on a side if the other three corners are occupied by 3.25 times 10 to the negative 6 Coulomb charges. Okay, so we have Q1, Q2, Q3, and here's where we're finding the electric field. So these are positive charges, so E1 will go up, E2 will go out, and E3 will go up. Okay, so the side length of a square, let's call this value D just to make it easier. So E1 is equal to KQ over D squared by definition. So it's along the x-axis. So E1x is KQ over D squared, and E1y is equal to 0. So for E2 will have an x and a y component. So E2x is KQ over 2D squared, since that's the distance here, and cosine of 45 degrees, since it's a square, which is KQ cosine of 45 degrees is root 2 over 2. So this is 4D squared. And this is the same for E2y, since sine of 45 degrees and cosine of 45 degrees are equal. E3 has no x component, it only has a y component, and its y component is KQ over D squared by definition. Okay, so the total E in the x direction is KQ over D squared plus K root 2Q over 4D squared. So this is KQ over D squared, 1 plus root 2 over 4. So if you need to review your algebra to do that, then I suggest you do so. So EY is KQ over D squared, 1 plus root 2 over 4 as well. So the total electric field E is equal to the square root of EX squared plus EY squared, which when you plug in values, since we know what K is, we know what Q is, we know what D is. So K is Coulomb's constant, Q is 3.25 times 10 to the negative 6 coulombs, and D is 1.22 meters. So we get 3.76 10 to the fourth in units of newtons per coulomb. And theta is equal to the inverse tangent of EY over EX, which is 45 degrees.